Hey, what is good? Welcome back to the channel. In today's video, we're gonna add a really cool feature, and that feature is essentially going to allow us to basically watch files, right, and then listen for any changes to those files. For instance, if we were building a hot reloadable feature for our engine to be able to hot reload a game DLL at runtime, what we want to do essentially to make that work seamlessly is basically watch for that DLL file and listen for any modifications made to it. So if we recompile the game DLL, then this file watcher will essentially detect that change and then basically propagate or send an event to any listeners who are actually listening for that change. And then those listeners can then basically trigger a hot reload event and then have the game hot reload at runtime, or whatever file it is that you wanted to basically hot reload at runtime, or whatever changes that you want the engine to do when a specific file that it's listening to gets modified or changed or updated. So let me close our engine window here, and I'm going to go to an example project, my isolated testing grounds here, to basically illustrate what we are about to add here. So in the previous video, if you haven't watched that one, we essentially added the ability to load dynamic libraries on the fly at runtime. So in this video, we're gonna basically add a file watcher to basically allow us to listen for any file changes on disk. So let me demo this, and before we actually implement it in the actual engine, I'm just gonna demo it using a isolated project, a testing playground, I guess, a playground, I guess. I don't even know what to call this, to be honest. So let me give you a tour again. So we have a bin folder here, and we have an application, our executable. Then we have the renderer plugin, right? And then we have a file that I just added. You'll know that if you watched the previous video, we didn't have this file in here, right? So this file just contains hello world. And what if in our engine, this file was like, I don't know, a shader, for instance, right? So we could basically watch that file for any changes. And if any changes occur to that file, we can basically trigger like a shader recompilation routine, and then basically just compile our shaders at runtime without having the application quit on us. And so forth, and then we can basically see those results happening in real time. So let me just demo this. I'm gonna run this app real quick, and here our file watcher is essentially just telling us that hey, we've basically registered one file to watch, right? And that's gonna have an ID of 0, and then we're gonna have another file to watch, which is in this case is a test file.txt, and that will have an ID of 1, right? So how does this work? So let's go ahead here and let's do a modification to this text file. So let me just say hello game tools engineers, because we're building game tools here. And I'm gonna save this, and I want you guys to pay attention what happens here. So I'm gonna click save right now, and boom. So this basically got detected, and then it basically says hey, a file called testfile.txt was recently updated, and then it gives us the new timestamp, and then it just gives us a warning saying that hey, a file that was being watched got updated or written to, but no callback handler was set. So we didn't really set any callbacks to basically handle this change, but we do know that a file update was basically triggered, right? We do know this happened, but we didn't really do anything to handle that in our application here. So essentially this feature is what we're going to be adding to our engine, and to illustrate how this would also work for dynamic libraries. For example, we're listening for this dynamic library change here. So for example, now if I recompile this dynamic library, our dynamic library is called a plugin for now. So I'm going to recompile this on my make file. So on this side of the console, I'm just going to say make plugins. This will just recompile our plugin binaries. So I'm going to hit enter, and I want you guys to see what's going to happen here, and I'm going to explain what you see. Okay, so I'm going to hit enter in 1, 2, 3, and boom, we just recompiled, and here we got new messages, right? So what we're reading here essentially is just a message that says a file that was being watched got updated, but no callback handler was set, right? And then down here, you'll see that a file with ID 0, in this case being the lib, right, our renderer plugin.dylib, has been removed from the list of file watches to watch. But wait a minute, I didn't really remove this plugin, right? I just recompiled it. Well, if you think about it, when basically you have a dynamic library loaded, right, and then you make any changes to that, well, in this case you recompile it, right, you kind of get locked out of it. And sometimes you get locked out of it, or it just gets deleted for like a millisecond, but that's more than enough for your application to detect it as a deleted file, even though just a millisecond later the file gets back into that same directory with new content in it, right? So it gets registered as a file deletion, and this is what we will handle in the future when we actually implement hot reloading. I'll show you guys how to handle a situation like this, whereby it shouldn't detect it as a deleted file, but rather as an updated file, because we're going to implement like ability to sleep for a minute and then check again and do this and do that and all of that stuff, right? So enough yapping around. Let's actually code this bad boy. All right, so let's get back into Xcode. And again, for those who are new to the channel and are watching this video for the first time, or this series for the first time, and you didn't watch the previous video, the only reason I'm working in Xcode is because we still were making some changes to our platform layer, which is written in Objective-C, but the rest of the stuff, our systems and everything else, is written in C. So yeah, so that's the only reason why. And once we're actually done with the platform layer, we're then going to migrate our project to an VS Code project, and then we're going to work in here entirely, because then we'll only be focusing on C and all of that stuff. So we're gonna build our renderer in C, we're gonna build everything else in C. So do not worry when you see Objective-C file here. We're actually not even using Objective-C in this instance. We're still using C, because we're not really doing any platform specific stuff, to be quite frank. Yeah, so let's get on and let's create this FileWatcher. So how are we going to do this? So I'm going to go into our platform.h file here, and I'm going to go down here, and just below the dynamic library management stuff, I'm going to put in the file watcher management stuff, right? The word management, I'm just throwing it in there. Really, there's really no meaning at this point. I'm just using these comments to separate my functions. So what I'm going to do now is I'm going to create a boolean function, a function that returns a boolean, and I'm going to call that platform watch file. Okay, and this function is going to watch a file, so we're going to give it the path to the file, right? So we're going to do a const char, and I'm going to say file path, and then we're also going to give it the ID of that file for it to set for us. So that's going to be a U32. So we're going to go U32. It's going to be a pointer, because this function is going to set that file, that ID for us. So I'm going to call this file ID, and then I'm going to have another function down here called platform unwatch file, like so. And then the only thing we pass in here is the ID, and it'll basically find that within a list of files to watch, and then just remove it or reset it in this instance, or whatever we choose to do, right? So now we have the ability to watch a file and the ability to unwatch a file. And I think these are the front-facing functions that we want. There's one called platform update file, but that will be internal to the platform layer, so you'll have to implement that in your own platform layer. In case you're following along and you're building your own version of this on Linux or Windows, then you might want to implement that in your Windows layer or your Linux layer. But in this video, I'm only focused on Mac OS. However, the knowledge shared here should be cross-platform enough for you to at least figure things out, right? It might not be exactly for that platform, but it should be enough for you to figure things out, right? So yeah, anyway, let me go back here and see if we actually did that right. Yes, we did. So all I'm gonna do here, I'm just gonna copy these files, these two lines, I mean, then go back to our platform layer, and I want to basically put this right here, library unload. So let's see, dynamic library unload, and we just want to put it right below this function, and we're just going to open up these two functions here, like so. And for now, we're just going to return true. And here we are going to return true. Sorry about that. Return true. Okay. So before I can implement any of this, essentially, I need to basically make sure that I have all my necessary structs for this. So what I'm going to do now is I'm going to go all the way back to the top of this platform layer. And I'm going to look for a place whereby I'm defining most of my structs. So where is that? Just bear with me while I find it. And that should be right here. So we have platform specific things here. So just above the platform state struct, I guess we can put this. So I'm going to create a type def struct. And this one will be the file to watch, because we're watching files, right? So this file will just be called file to watch, and it's going to hold the file metadata, right, if I may call it that way. So let me just copy this. Oh, my bad. Let me just copy this, paste it like this, save. And a file has what? So our file in our instance is going to have a U32, which will be an ID. So it was going to have an ID, right? So each file will have an ID. And then we're going to have, each file is also going to have a path to that file. So it's going to be file path. And then each file will have the last written time. So the last modification time, or the last modified time. So const char last modified time, like so. Last modified time. Hopefully I spelled that correctly. But yeah, right. And then we're going to create another struct to hold or to act as an array container or something like that. So let's do type def struct here, and then I'm going to call this files to watch. It's a plural, not a single, not singular, because this one is single and then this one is plural. There's an S in here, so do not get confused. So files to watch, this one will hold or act as a container for a list of files to watch that we've registered to watch or whatever, right? So files to watch, like this. Okay, and I'm just gonna copy this name, put it down here, and that's about it. And then what are we gonna have in here? So in here we're gonna have a list of files that we're currently watching. Okay, so that will be file to watch. And actually I want to make this a capital T, just to be consistent. And file to watch will be an array. That's why I'm putting a pointer there, because it's going to be an array of files to watch, and I'm going to call it to watch, and I'll explain why I'm naming it this way again. If you watched my previous videos, you do know that I'm quite picky with how I name these containers. So yeah, and then I'm going to have a U32, and this one is going to be the count, which is going to be the number of elements inside this array of files to watch. And then we're going to have another U32. In this case, it's going to be the capacity. So capacity of the array is because we can basically have more capacity than the number of elements. So yeah. All right. So now that we have this, all I'm gonna then do is, I'm thinking, where should I actually put this? Tisk. This one is for our windows, so this one is for the platform state. So I guess we can hold a list of files to watch in our platform state. So what I'm gonna do now is I'm gonna say files to watch. I'm referring to this container here because it has an S, not the one above. Okay, so files to watch. I'm gonna call this files. Okay, and this is essentially a container that has a list of files to watch. Okay, I think that's about it, really. And what I want to do up here, in fact, actually I should have done this in the platform.layer. So right here I'm just gonna create some function pointers, but I'm gonna basically type def these. So void and these will be our callback functions, right? So I'm gonna say file watcher, file deleted, I guess. Yeah, watcher deleted callback. So this will get called when a file gets deleted. We can register this callback. So it's gonna take in the file ID, so 32, and then a U32, which will be the file ID like this, and then we'll have another callback which will basically listen for, or which will actually call when a file gets written into or updated. Okay, and that's about that really. So that's all we need there. So FileWatcher, file deleted callback, FileWatcher, file written callback. And all I'm gonna do is I'm gonna come back in our platform layer, and just below this guy here, I'm gonna basically create variables to basically so that we can basically set those function pointers, right? So if we call it file watcher file deleted callback, and then this one will be named watcher file deleted call back like this, and then this one will be file watcher file written callback, and just rename this to written like so, right? So these will be the callback functions that we can basically set, and now because we have this guy and these guys, so we need to modify our initialization routine, and then which is this one right here, right? So platform initialize. So we basically initialize in an array of our windows, and then basically set this variable. So right after that, I'm just gonna put a comment here just so that we know what we're dealing with here. So initialize FileWatcher stuff. yeah, I'm just gonna keep it like that really. So I'm gonna do iState, and inside of iState we have now I believe files. So we can say files dot to watch, and then we just want to malloc memory for this, so size of and this one will be, let's go back to that struct. So files to watch, file to watch, so that will be file to watch like this. Expression is not assignable. What do you mean by that, my guy? What am I doing wrong? I state files to watch, malloc size of file to watch. Did I make a mistake somewhere? Let me see. Watch. Oh. Oh, you know what? I'm fine. It's okay. This is not a pointer. Yeah, and I'm accessing it. Wait. Yeah, it's not a pointer, so expression is not assignable. Hold on, take me back here. File to watch. Am I missing something? I guess I don't have to, because this gets allocated for me. Hold on, where am I? Where is it? This gets allocated for me on the stack, I guess. But then does it allocate memory for this though? Well, it's a pointer, so it's not necessarily an array like this. So I guess I can just set that to 0, right? I guess. Right? Yeah. So let's go down here again. And then let's say iState files to watch, and I guess we can just do that like this. Will that be happy? Expression. Okay, maybe I'm missing something, but I guess I don't need to do that then. But what we could do is state slash why am I not getting IntelliSense though? Watcher, hold on. Why am I really not getting IntelliSense? This is not a pointer. This is something I forgot to fix actually. I was actually supposed to fix this a long time ago. That is why everything I'm doing is really not working out. So, this is supposed to work, but it's not working because of this, right? Because it's not a pointer, right? So now when I do this, it works. Wow. Okay. 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 Yeah, that works. So in theory, I could then just say size of file to watch. Sorry about that, guys, but sometimes you mess up. But indeed, this is something I have to fix. I have to convert this to a pointer, because that's what we're doing in all the other systems, just so that we can have everything consistent and all of that, and we can basically handle memory and all of that correctly. But for now, this is what's gonna work for us, right? And I'll refactor this at a later time, or I'll have a video dedicated to refactoring all the little quirks and mistakes that I've made. So yeah, all right, so let's move on. Sorry for wasting time. So let's do iState, and again, don't get confused. So let's set this to 0 like this, and for the written one, let's also set that callback to 0. We just being clean with our code, so making sure that there are no dangling pointers or anything like that. So yeah, so once we have that set up, all we want to do now is come down to the part where we basically gonna say platform watch file. So here, essentially, we are going to register a file, and then we're going to add it to that array that we just created, right? So to do this, I'm going to create a separate function, and I'm going to make it static so that it's just scoped down to this file, and you can't access this outside. So, and it's going to be Boolean, and we're basically going to register a file to watch. Okay, and this is going to take in the same parameters that this function basically takes in. So I'm just going to copy those up here, and then I'm going to open up this function, and all I'm going to then do is I guess we can rename this to out, because yeah, like so. And just bear with me real quick. FileWatch FileWatch, this can be the out ID. Just save that and come back here, and that should be fine. This one is perfectly fine. So let's implement this function here. So let's do some sanity checks. So we're gonna check if basically we have a file path, and we're also gonna check if we have the ID to basically populate, and if these don't exist, then we want to return false. Okay, we want to return false, but because we're saying an or here, this could be set and this not set. So we can check, right? We can check and be like, okay, if out ID does exist indeed, then all we want to do is just basically set that to an invalid ID of some sort. So an invalid ID of some sort for us, I guess we can go to our defines here, and then we can just say define invalid ID, and then this will be like the maximum number of an unsigned integer. So I believe I have it in this code base, and yes I do. Okay, sorry about that. Okay, sorry about that. So I'm just gonna paste that here like so. So this will be an invalid ID. This is just the maximum number that we can basically have in an unsigned integer. So back into our platform layer, we can just say invalid ID like so. So we just set that to an invalid ID, and then return out of this function if we don't have either of these set or passed in. But then if we do, then all you want to do is say, okay, fine, out file ID. We still want to set it to invalid ID for now. And then we need to basically ensure that we have enough space in our array, because we want to add this file to watch to an array. And if you guys have been watching my previous video, you know there's a pretty cool function that we like to reuse and that is called resize event array. So I'm just gonna put this up here, and I'm gonna rename this because we need to rename this. So this one will be called resize files to watch array. So files to watch array, and all we need to then replace this with is basically the files to watch container, and then we're gonna rename this to list like this, and this should be a list. I could have just used a search and replace, but oh well, I've come this far. And then this one should then be a file to watch. So file to watch, make sure it's singular, not plural. And then this one will then be the new list of files, so new files list. And then we're gonna basically reallocate that list. So list, and then instead of events here, it'll just be files. Is it files? It's not us, it's to watch, right? List to watch, the files in that list to watch. And then here we have to replace that with, I believe it's just file to watch, like so. Okay, and if I save, we find there, and then instead of returning new events, we just return new files list. We check for if the new files list actually was allocated successfully, and then if not, we return out of here. But if so, then we just set, right, hold on, we just set these properties. So list, and then instead of events, that would be to watch. This will be the new files to watch, new files list to watch. Capacity, implicit configuration, conversion loses integer position. Again, I believe in the last video I asked which is better, size T or a U32. So hit me up in the comments, because Xcode is suggesting I use a size T. Yeah. All right. So just save this. And I think this should work for resizing the files to watch array. So down here, I'm just going to put a comment here. So that was just going to say ensure there's enough capacity in the list to basically store this newly registered file to watch. So let's do an I state. And in here, basically, we're just going to do, again, it's not a pointer, so files dot to watch. Actually, no, we need to files dot count essentially, and we want to compare that with I state dot files dot capacity. So if it's greater than the capacity, then we need to resize our array. So we're going to do that by just calling if this. So resize files to watch array, and then we're just going to pass in the array that we want to resize. So I'm going to say I state dot files. Okay, so resize that array for us, and if it failed to resize, then we just return null. If not, then it's successful, and then we just go out of there. So once we've ensured that we do have enough memory or space in our array, we essentially need to basically get the file info. So I'm going to do a struct here, struct stat. That's funny. I didn't import that, but Xcode is picking it up. Okay, so file info like this, and I'm just gonna click on this and see, and yes, Xcode is picking this up. Wait, do we already have that imported? Let's see. We don't. Yeah, we really don't. I feel like this is just an Xcode thing, because sometimes I do know that Xcode imports these things for you somehow, and then when you run, it'll be like, this file is not found or something, or it doesn't exist. So I'm just gonna do a sys and I'm going to say stat because that's what I'm making use of here. So back over here, stat file info. This is what we're going to use to basically get file information, okay, or information about that file that we want to watch. And then we're going to store result from that. So we're going to say stat, and we're going to pass it the file that we want to watch, or get the stats off essentially. So file path. Then we basically going to store the information of that file, the metadata, if you might call it, into file info, which is this guy up here. And once we did that, we're gonna check if it was successful or not. So we're gonna check if result is not equals to 0. Then what we want to do is we want to check if the error that we got, essentially. So I'm gonna do error no. And again, Xcode, I did not include that, but anyway, I'm not gonna rely on that. But yeah, let's just do error no.h, and then come back down here again. So if the error that we got is not of type, it's not equals to, what was it again? Is it ENOET? And I believe if I click on this, it says no such file or directory. That's what that error code means. Okay, so I'm just gonna copy that and then just do this, right? So if the file doesn't exist, okay, if file does not exist like so, just print f something. Okay, so we know that it doesn't exist, so file does not exist, therefore print something. So I'm gonna print file to watch does not exist. Okay, like so. And outside here, I'm just gonna return false. No, false, like so. Yeah, and that's what we want to do. So we're checking if the file does not exist, then we print out a message they're saying that the file to watch does not exist, and then we return false because the file does not exist, right? However, if the file does exist, meaning that we didn't get any errors, right? We basically just want to loop through the list of files and look for an empty slot. Okay, so I'm gonna do int I equals to 0, and then we're gonna say I less than I state, and I'm gonna do, again, it's not a pointer, so files.count, and then I'm gonna do I plus plus, like so, and then we're gonna loop through our array of files to watch, right? And then we basically gonna see if we have an empty slot to put this file to watch inside of. Okay, so I'm just gonna do file to watch, and I'm going to name this file, and I'm going to make this a pointer because we're just taking a reference, and then I'm going to say at I state dot files dot to watch at that index. We're going to take that file, and then we're going to do some checks on that file. So we're going to say if we found a file, and if this file, let's do file.id. So if this file ID is equals to an invalid ID, meaning that it means that we have an empty slot, okay, a free available slot. So I'm going to put a comment here. We have found a free slot to use in the array, right? Because we can unwatch a file but then not deallocate that memory, right? We just reset the metadata to invalidate it, and then if we want to watch a file, we can basically check if we have a slot that has invalidated data, and then just give it new information instead of completely removing it from the array. This will just help us with not having to deal with deallocations and reallocations of the array and resizing the array every single time, right? So yeah, something like that. Yeah, so we have found a free slot to use in the array. So all we can do is take that file ID and then just set it to a new validated ID, in this case the index, and then we can say file path is equals to the path that we pass in. So that will be file path, file path like so, and then we can say file, and then we're going to do the last modified time, and this is where this variable that we created up here comes into play. Okay, so we're going to say the last modified time is equals to file info, right, which is this variable here, which got set by the stat function over here. Okay, so in that we have some pretty nice things. Okay, in our scenario, what we want is this guy. So if I just click enter here and I just go to the implementation of this, essentially what that guy stands for is where is it? Just want to show you guys, if you guys don't know what these things do. A time. Yeah, it's not that one. It's this one. Wait, at time. It should be spec. Here it is, right? Here, yeah, m times spec, which is the last time or data modification, right? The time of last data modification. All right, but the one that we want is this one. Okay, where is it? M time, last data modification time. Still the same thing, but this one is a macro defined somewhere else, somewhere up here, somewhere. You guys will find it, but I do know it's a macro. So that's what I'm going to use. So instead of typing the spec there, I'm just going to say time. Okay, and then we're going to get incompatible integer to pointer conversion from const char from down time. So that's very interesting. Last modified time. So does it have a fix for me? Oh, I'm actually using the wrong thing. There should be m time. M time, but it's still crying though. Incompatible into conversion. I'm gonna leave it for now. Xcode things, so I'm gonna leave it for now. And I'm gonna do out file ID, and I'm gonna set this one to be equals to the same ID we've just set over here, which is just the index. So like this, and then we're gonna return true. Okay, return true like this. And I think that's about it for here. So we basically look for an empty slot, and then if we found one, we just basically add or reuse that slot, right? However, if we didn't find an empty slot, right, we basically just want to push this thing to the array. Okay, so what we want to do is the same thing we did in here, but outside. So we're gonna say file touch, and that will be file, and we're just gonna initialize it with 0 here, and then all I'm gonna do is say file.id equals to istate dot files dot count. Okay, and then what I'm gonna do is I'm gonna say file dot file path is equals to file path that we passed in when we call this function, and then all we want to do now is just say file dot last modified time. This should then be equals to file info dot stm/m time, like this, and I'm gonna save that. And then what else do I want to do? after saving that, I want to set the ID, the out ID as well. So I'm gonna have to do out ID equals to ID. Actually no, it's equals to istate.count. So I'm just gonna copy this like that, and then basically we have the file that we want to add to the array of files that we want to watch. So we're gonna add it. So let's do istate.files.toWatch, and we're gonna go through the index that we want to add this at. So istate, then I'm gonna say istate files.count. Then we're gonna add this file. Okay, and then from there we're just gonna increment so that count. So istate.files.count, increment it like so. Sweet. And then all we want to do now is return true. Okay, yeah, it's to return true. So what are we doing? So register watch, we do a sanity check to see if we've passed in any of these guys, and then basically if everything passes there, then we basically just ensure that the ID is invalidated at first, and then we check our array if we have any capacity, and then if we do have capacity, then we move on, and then we basically if we don't have capacity, we create capacity for that, and then we basically query file metadata of that file that we want to add, and then we're going to check if that file actually does exist, and then if it doesn't exist, we boot out here because there's no point in allocating it to the array or moving it to the array, and then from there, if it does exist indeed, then we basically look for an empty slot to slot it in the array, and if there isn't an empty slot, then we just do this. Okay, we just slot it in at the last available slot that we do have, that hasn't necessarily been initialized with any file to watch data. So yeah, so then we can move on to platform FileWatch, and all we do here is just return register watch, and then we just pass in the file path and the out file ID. And now we can move on to file onWatch, and this one hopefully it should be small to basically tackle, and I'm also just going to create a separate function for this, and I'm going to call it static because we are going to reuse some of these functions somewhere else. Okay, so we're going to do boolean, and then we're going to say unregister watch, and this one just needs to take in the file ID, so I'm going to copy this over here and open this up, and then we're going to do a sanity check. So we're going to do if istate, because we do need our istate, if that is not there, and also if istate files to watch do not exist, meaning we don't have any files to watch, then we basically just return because there's nothing to unregister, right? Because the array doesn't even exist itself. So yeah, and again, I can't necessarily check for this because it's not a pointer, which is why I said I have to refactor this at some point, and I'll do a video dedicated for that. But yeah, I don't want to do this right now, so I guess we'll just check if we have any files to watch. If not, return false. And then all we want to do is do another sanity check, and we're going to say istate, and we're going to say it's not a pointer, so files, istate of files.count, and then we basically want to check this condition here. So istate files to watch, and whether the file ID is greater than istate. So istate files.count -1, and if that's the case, then we also just want to boot out of here and return false. However, we can basically just reset. We're not removing memory or deallocating that space out of the array. We're just setting the file in that array to an invalidated file, which we can then reuse when we register a file. Hence why we're doing this check here to check if there is a file already there that has an invalid ID, and if so, just override the data and just save that inside instead of having to reallocate memory all the time, right? We only add a new file if there isn't any empty slot. Okay, so reset the file metadata. Essentially, again, this slot now becomes a free slot, right? The slot at this index becomes a free slot. So then we're gonna say file to watch file, it goes to istate.files to watch, and I want the file that I want to basically invalidate, and we're gonna get that by just saying istate files.count, but we want the index, so count will always be ahead of an index by 1, so we just want to subtract 1 from that, just so that we index in the correct file, and then we're going to say file.id and just invalidate that ID. So invalidate ID, and then we're just going to say file path is 0, so it doesn't really point to anything, and then file.last modified time is also 0, like so, and then we simply return true, and that is our function. To unregister FileWatch, and all we do here is just call it in this public API call. So unregister watch, and we just pass in the file ID to unregister, and from there I think we are almost done. The only thing that we want to do is basically query for these changes in the main loop of our platform layer. So for that, we are going to create another static function which is only visible in this file. So we're going to call that void update, right? So platform update watches, like this, and it takes in nothing, so just set that to void. And this might be a little bit lengthy, but the logic is pretty simple, so let's get to it. So we want to do a sanity check as usual. So we're gonna say we're gonna check for istate and files to watch, see if indeed we do have a list assigned. If not, we just return because there's nothing to update and to basically query and so forth, right? But if we do, then all we want to do now is iterate through that array of files that are in that list. So we're going to say I less than I state dot files dot count, and then I plus plus, like so, and then inside all we want to do is have a reference to the file to watch. So I'm going to make that a pointer file. It goes to I state, should be a reference, so I state files to watch, and I want the file at that index to watch that I'm watching, and then we're gonna do this. So we're gonna do if file, the ID of that. So if file dot ID is not equals to an invalid ID, meaning that we have a valid file, then we're gonna basically check, okay, and get its file stats. So all we're gonna do is say struct stat, and then we're gonna name this file. Guess we can just say file. We can name this file info, like this, and then we want to get the result from the stat function, because we're gonna call stat and be like, okay, get me the files of the following file. So I'm gonna say file dot file path. And then we're going to store that metadata in this file info variable here. So file info. Now that we have the metadata, we can check if this result was successful or not. So yeah, we just do, if it's not equals to 0, then we check. So essentially what we're checking is, what is that? Is this. So I'm just gonna copy that instead of having to retype and come back in here. So we're gonna check if it does exist. So file does not exist. So if the file does not exist, we are then going to trigger those callbacks that we can basically trigger if a file is deleted, right? Because if it doesn't exist, obviously the file is deleted, right? Because we were listening to it, meaning the file was active, but for some weird reason now we can't find it anymore, so therefore it means the file can only be deleted, right? So file does not exist, meaning it was deleted. Okay, so let me just say anymore because it did exist. Okay, meaning that it was deleted, and then because of that, I guess I can remove this, but I'm going to copy it because I'm going to need a printf somewhere. So we are then going to trigger. So let me say this trigger our file deleted callback. Okay, so we're going to do if iState dot FileWatcher deleted callback is basically assigned, then we're just going to call that. So we're going to say iState dot watcher file deleted callback, and we're just going to pass in the file ID. So file ID, and be like, hey, this file with this ID has been deleted, so do whatever you want to do on the application side of things. Otherwise, if this callback was not registered, then we simply just want to print a message here and just say file to watch. So let's say a file that was being watched, okay, got deleted, but no callback handler was set. Okay, and we're just gonna do a new line character there. Okay, so this is just a warning, so warn, because essentially we want to have callbacks set whenever we listen to a file, so that we can react to any changes to that file. Okay, so yeah, we do that, and then basically now we know that the file got deleted, so it's only natural that we just unregister it, and this is where our static functions that we just did come into play, because we need to reuse them here. So I'm gonna call file ID like this. Okay, so I'm gonna unregister that file, and then we can basically print out something as well here if you want. So I'm gonna put this in here, and I'm gonna say some. I can just say a file with ID. How do I ID? Then we're gonna pass in the ID and name. Pass in the name has been removed. Okay, from the list of files to watch. Okay, and I'm just gonna put a new line character there. You don't have to print this message, but I'm gonna put it in here so that the time we get to use all of this, we can basically see it in action and actually working for debug purposes. But yeah, so what is this? This is a decimal, so we're gonna do file ID, then we're gonna say file path. Okay, and that should fix our problems there. And then because we are in a loop, we going to continue. Okay, otherwise let me see, otherwise the file does exist. So what we want to do is essentially, then if the file does exist, meaning this didn't get called, but then we have some other error instead of the file does not exist error, then I guess we could just print out something here, I guess. So we can just say printf some other error occurred that we should probably handle. And I'm just gonna leave it like this for now. Okay. Yeah, and then outside here, again, I'm just gonna put a note here because indeed other errors can occur other than this ones. So I'm gonna just put a note here and say that it's possible that other errors could occur. So we should probably handle them. Right? This is a question mark for me and for you. So yeah, and because you're still in a loop, we continue. I think that works. So this should work essentially. And yeah. So what else do I need to do in this function? So essentially we've checked, we got the file metadata, and we essentially are checking if it exists. And if it doesn't exist, we basically hit or basically trigger our callbacks for file deleted, and then anything that's listening to that will then basically handle or react to that file deletion, and then we basically remove the file to be watched from the list of files to be watched, and then we continue here. So then outside of this, which if the results, so we check in that. So outside of that, we basically check if the file has recently been updated or not. So to do that, we can do an if statement. So we can say file info dot st m time, like this, stm time. If that, right, we're gonna check the difference. So file, how do I, file last modified time, and then we're gonna file info dot sm time minus the file time that it was last modified at. So if this is not equals to 0, okay, then probably should just put a what's this? Invalid binary expression. I did something wrong. stm time file. Did I really do something wrong? I guess stm time spec. My goodness. Can't I do this? Long const char. The other one is a const char. But how? This is so weird. Okay. Let's see if this works. But okay. Right. So we're gonna print out a file. This still cracks me up, but anyway, a file as was recently updated. So if this file difference is indeed different, then we do know. So let me just put a comment here. So check if the file has been recently updated, okay, or not, and notify listeners, because you're gonna notify listeners if it was, if that was the case, meaning that it was updated. So can't spell today. Anyway, so let's do that. So let's say a file was recently was updated recently, and then we're just gonna put a new line character there, and then we're gonna say file. It's gonna pass in the file path. So let's do file path like so. So a file was recently updated, so we'll know what file that was. Again, you don't really need to print this out, but again, I say we're still going to need to test this in future, so these are just there so that I don't have to put them. And then we're going to do file last modified time. We're going to update this to be the file info dot st/m time. And then I guess I learned a new trick today. We just need to do a const char, convert that to const char. By the way, I don't really have to do this because in Xcode that's not what we're doing, right? But I guess Xcode has its own things that it does and checks for us, which is pretty good, because then I guess it can prevent me from making mistakes. But again, if I just do a quick search here for stm time, you'll notice that over here, right, stm time, that's what I'm using, and I'm not getting any compiler errors or anything like that, or warnings or anything like that. But in Xcode, I am getting those, which is pretty weird. But it's new to me, but oh well, let's see if it works, right? So yeah, so we've updated the last modified time to be the new modified time, and then we're just gonna print f timestamp. I mean, we could, just for the sake of debugging, right? We don't have to, but I'll just do it, because in future I'm still gonna test this and fix it for any issues and so forth. So yeah, let's put that in here, and I'm going to say file last modified time. So after doing that, we need to then modify our listeners as we are saying. So let's just do that. So notify listeners like so, and then we're gonna do and check. We're gonna do the same thing we did up here. So I was gonna copy it, but I guess I can just type this. Don't be lazy. That's a message from me. Don't be lazy, guys. This one will be calling the written callback, so we're going to check if that was set, and if it was, all we do is just call it. So I stayed watcher file written callback, and then obviously we just pass in the file ID like this, and then we'll basically call any callback that was registered to handle that. And then here we're going to say else if no callback was registered. We can just copy the same message that we have up here, and we can just say warn file that was being watched got updated, but no callback handler was set. You probably should set that. So yeah, and then I believe that is it that we need to do. Oh wow. Anyway, I guess we can test this. Wait, what? Us? Okay. Let's see. Interesting. Okay. Can I test this though? How will I test this though? I don't know. How will I test this in Xcode? You know, I've never really used Xcode in this sense, because we're not really going to be using Xcode for the other parts of our engine. I guess we could just end the video here though, right? Let me just run this and see if we broke anything. But then essentially, for those who wants to test this. It should work the same way that I showed in the beginning of this video. It's just that I don't know how I'm gonna test this in Xcode. I guess we could try. If it fails, I'll just end the video. So yeah, I guess for those who wants to watch me fail, I guess why not. So this can only work once we have the platform initialized. So what we could do then is say platform watch file, and then I'm gonna give it the file, and then the ID we can just have like a, I guess maybe a 32 ID maybe, and then just pass in the ID, and then do it like this, and then the file to watch, essentially, I guess we can do products, then open a new window, show in Finder, right? And then maybe here I could, I don't know. Let's see. Test file.txt. Right. We should get an error if it doesn't exist. So let's run this and see. File to watch does not exist. Yes. So we got this message here saying file to watch does not exist. So, however, I'm not liking the fact that we don't have a new line. So where are we printing that out? File. Let's say file to watch does not exist. So let's put a new line character here, and then come back to the main file here. So file to watch does not exist. So products. Can I add a new file? Let's see. What kind of file? Empty file. Yeah. And then let's call this test file.txt create, and that should be in products. And then let's see if it finds it though, at least, right? So file to watch still does not exist, so it's not there. Can I put this here? Nope. Wait a minute, this is an Xcode thing, right? So let's do copy files. Absolute path. How did I do this before? I really don't know. So yeah, I don't know, guys. But yeah, we tried. So if you guys know, let me know how to do this in the comments section below. But yeah, I'm gonna remove that for now. But worry not, we are actually almost done with our platform layer anyway. So we will move out of Xcode and we will be able to test most of these things. The only thing I believe that's left for our platform layer is to basically add the ability to get the absolute time, and the ability to basically sleep, and then the ability to basically copy files. And then what else? I think that's about it, really. Oh, and the ability to essentially set the Vulkan layer, surface layer, but that will not be specific. I think we could just create another way to just expose the layer and then handle that in the Vulkan renderer itself. So that is not truly an issue, but I do know that we still don't have a layer to render to in our window, right? We have the view, yes, but we still need the layer, the metal layer, right, to basically render to. I haven't set that up yet, but we will do so in the coming videos. So fear not. And I think once we have that set, we'll be done in Xcode, and then we can move on to VS Code and code the renderer and everything else there. We still need a few other stuff, such as a logger system to log to the console, but it shouldn't be too much work. And then I think once we had done with that, we can set up Vulkan. Yay! So we have like just maybe a few more videos to go before we can set up Vulkan. But after that, I think we would have like a proper platform layer that can do quite a lot of stuff. Right, we have an input system, we have an event system, we have a FileWatcher system, we have what else? We have a dynamic loading capabilities to load dynamic libraries at runtime. So we basically have a pretty good solid foundation so far, which is basically what we need essentially to get the ball rolling, right? So yeah, I'll see you guys in the next one. Cheers.